What's up, everyone? Today in IB Applications 1, we're going to talk about distance, area, and volume in 3 dimensions. So let's get into it. So first we have our formula for the distance between 2 points, again in 3 dimensions, and that means that each point has 3 coordinates, the x-coordinate, the y-coordinate, and the z-coordinate. Note that this formula is given to you in the formula booklet on page 6. So let's use it in an example. Example 1, a storage box for garden tools is in the shape of a cuboid, which is IB speak for just a prism, and it's shown in the diagram. Vertex A has coordinates 2, 3, 4. So we have vertex A over here, and it has coordinates 2, 3, 4, which means we have the x-coordinate of 2, the y-coordinate of 3, and the z-coordinate of 4. All coordinates are given in meters, it says. And we are first asked to determine the coordinates of vertices R, C, B, and Q. All right, so let's start with coordinate R. And I'm going to write them in the same way that they wrote A in the diagram. So R and parentheses. So if you notice that R is along the x-axis, and it's on the same kind of front plane as Q, A, and D. So it's on that front square. So what that tells me is if it's along the x-axis, the only non-zero coordinate I'll have is the x-coordinate. It's just like having an x-intercept in a normal plane. So if it's on this same front plane of this cuboid as A, that means it has the same x-coordinate. But then the y and z coordinates are both 0, because again, it's along the x-axis. C, vertex C, will be the same kind of idea. Vertex C is along the y-axis, so that means the x-coordinate and the z-coordinate will both be 0. So I'm going to fill those in first. My y-coordinate, and if you notice on that side plane, A, B, C, D, so that means my y-coordinate will be the same as my y-coordinate for A, which is 3. B, vertex B, is right above that. So that tells me, number 1, the y-coordinate is the same. So my y-coordinate will still be 3, but I've also gone up on the z-axis. So that means that A and B, even though it's drawn in 3D, so it doesn't look like it, but they are at the same height. So they both have the same y-coordinate and the same z-coordinate. It's just that B hasn't come out along the x-axis, which means that the x-coordinate of B is 0, but the y is 3, and the z is 4. Finally, Q. So similar connection with B and C. If you notice, Q and R are right on top of each other. So that means they both have the same x-coordinate. This time Q hasn't gone out along the y-axis, so its y-coordinate is 0. But it has gone up the same amount as A has along the z-axis, so the z-coordinate is 4. Letter B, asking us to find the maximum length of the garden tool that can fit within the storage box. So remember, length, it doesn't have to go this way, it doesn't have to go this way, but it can go diagonally. So if you notice, they even draw in this dashed diagonal line from the lower left RB, or R, all the way up to the upper right B. So we're going to look for that length, because that will give us one direction of the longest diagonal. So we're going to use that distance formula to find the length RB. All right, so referencing my formula booklet, or I can go back to the previous slide, we're basically just taking the differences between each of those points and squaring them all underneath the square root. So I'm going to take the x-coordinate of R minus the x-coordinate of B squared. I'm going to add that to the same thing with the y's. Y-coordinate of R minus y-coordinate of B squared. Finally, with my z's, z-coordinate of R minus z coordinate of b squared. And then I can either evaluate each of those pieces, add them together, take the square root, et cetera, or I can just throw this whole thing really just in my calculator, because remember, if IB doesn't say, then the kind of understood way of writing your answer is 3 sig figs. So we're looking at either the square root of 29 or approximately to 3 sig figs, 5.39 meters. Remember, it said all coordinates are in meters, so that's why I threw that M in there. Letter C, we're finding the height from R to Q of the storage box. So now we're finding this height. So you can try to complicate this just because you think like further down in the question it gets more complicated. Think about what that means, and even just looking at your R and your Q coordinates. We had already said they're right on top of each other. We had already said that Q has just been moved up in the Z plane. So that just means that its height is whatever its Z coordinate was. So that means it's 4 meters. Finally, letter D, the angle between diagonals BR and BQ. So we're looking at the diagonal between B to R and B to Q, that green line that they've drawn in the diagram. So we're asked to find this angle. So note that we have already found the distance from R to B, found that in part B. We just found or identified the height of the storage box from R to Q. And if you think about it again, hard to tell from the diagram, but if you have this triangle, this R to Q and this plane or the Q to B line meet at a 90-degree angle. So I'm going to redraw our triangle down here so it's a little more clear. All right, so redrawn a little bit, and I can also identify again, we found the height here from Q to R, or R to Q is 4. We already found the distance from R to B is, I'm going to use that square root of 29 just because, again, when you can use exact values to figure out another problem, do that. And we are looking for the angle between B to Q and B to R. So we're looking for this angle. So thinking back to our right triangle trig, I have the opposite and the hypotenuse, and I'm looking for the angle. Opposite hypotenuse means sine of my angle equals the opposite over the hypotenuse. So again, when you're looking for an angle, that's when you want to use the inverse trig function. So I'll use inverse sine of 4 over root 29 to find theta. And when I do that in my calculator or in Desmos, making sure that I'm in degree mode, I get 48.0 degrees, correct to 3 sig figs. 3 sig figs means you should have that 0.0 at the end.